What's up, everyone? This is LeetCode 973k closest points to origin. We're given an array of points where points of I is equal to xy, which represents, or x1, y1, which represents a point on the xy plane, and an integer k, and we have to return the k closest points to the origin 0, 0. So yeah, we're basically just given a bunch of coordinates, and we have to return k coordinates that are closest to the origin point. So for example, we might have 10 points plotted on this xy plane, and let's say k is equal to 3, we would have to return the 3 closest points to the actual origin, which is 0, 0. Okay. Yeah, and this is how we can find the distance between 2 points, right? Obviously, we would be comparing a specific point to what point? Well, we'd be comparing a specific point to the actual origin, which is 0, 0, right? So one way you can do this is you can go through all the points, right, and calculate the distance, and then sort all those points you have, and you can see which ones are closest to the origin, and then you can just return the closest k points. But the problem with that approach is you're adding more overhead, right? Because if you're let's say k is equal to 3 and you're returning the 3 closest points to the origin, but we have 10 points in total, well, we're doing unnecessary work, right? Because we're not returning these other like 7 points. We're only returning the 3 closest. So we're adding overhead, and that's not good. Okay. So the way we're gonna solve this actually is pretty clever. Is we're gonna use a min heap. Okay. So let's make our min heap, right? And our min heap is just to return the k closest points. And when we get the k closest points, we want to store that in our answer, and we want to return the answer. Okay. So first of all, so for any xy endpoints, right? And again, these are coordinate points. That's why we do xy. We're gonna say, okay, let's calculate z, and we can just call that x to the power of 2 plus y to the power of 2. Now, if you look at the Euclidean distance, right, the formula, we don't need to take the square root. It's just unnecessary. Again, just more unnecessary overhead. So we're not going to take the square root, right? Because we'll still have them sorted if we just do to the power of 2, right? Because let's say we're comparing the point -2, 2, right? That'd be 0 minus well, it doesn't matter if it's minus or plus because we're squaring it, so it'd be right, for the x it'd be 0 minus -2, right? That'd be 2. Square that, we get 4 plus 2, again, that'd be 4, so 4 plus 4 is 8. Right? We get 8, and then let's say our other point is what, 1, 3, that'd be 0 minus 1, square that, 1 plus 0 minus 3, that'd be -3, square that, we get 9, so we get 10. So these are our 2 points, right? Whoops. Now, regardless of whether we keep it like this or we square these, it's not going to change, right? Does that make sense? Like, the square root of 10 is still going to be bigger than the square root of 8, right? So we're not actually going to square root anything because, again, it just adds overhead that we don't need, right? So that's why I'm not doing the square root, and why you shouldn't either. Okay, so we're going to make this a min heap. We're going to append all these points, right? And we actually have to append this as a pair. Okay. And then we're going to do heap by and heap. Okay. And now, while we have k that's greater than 0, let's pop from our heap, okay? So we're going to say x, y, z, q dot pop And again, this is one of those problems where it is a knowledge check also on whether you understand and have knowledge about heaps. So if you don't, that's okay, right? Just learn them, put in your pocket, and use them for other problems, okay? But we're going to take the k closest points, and we're going to append the coordinates, okay? And should be it. Oh, I called it answer up here, not roots. We'll just call it answer, whatever. Okay. So when we're sorting it like this, it's sorting when we add like a pair like this, it sorts by the first element, right? So this min heap, even though we're adding z, x, and y, it's sorting by z, okay? So when we add, let's say, a bunch of numbers like 10, right, and some whatever, some coordinate pair, and then like 20, some coordinate pair, and then like 7, some coordinate pair, and then like 2 and some coordinate pair, and then like 15 and some coordinate pair. The min heap is getting organized based on the z value, right? Because it's the first one. Okay, so it'd be our min heap would be something like this, right? It would get reorganized, okay, according to the z that we calculated. And so when we pop, we're going to pop, right, from the small z along with the xy coordinates. So if k is equal to 3, right, these 3 points are the closest ones to the origin. So we would pop these 3 and decrease the k every time, and right, and eventually k would be 0. And so we'd exit the while loop, okay? So I hope you understand what this problem is asking. It's basically, we have a bunch of points, and we have to find we have to return a list of the k number of points that are closest to the origin, right? So here, for example, we have 2 points. K is equal to 1. We have to return 1 point that is the closest to the origin. It'd be this point, right? This picture is kind of hard to tell, but you get the point, I think. No pun intended. So yeah, kind of a simple problem and solution. I think this problem is really just a knowledge check on min heaps, personally. So if you don't know it, min heaps, just, look those up, learn them. Pretty simple data structure. But yeah, I don't think this problem is too complicated, to be honest. We've definitely done a few more medium problems that are a little bit more complicated than this one. This is probably the easiest medium problem on Grind 75, I would say. Because you can solve this problem a little bit less efficiently, but like the way that I said about sorting, I mean, you can do it like that without using a min heap. So that's how I first solved this problem. This problem is kind of the easier one out of all the Grind 75 problems that are medium, personally speaking. But anyways, I hope this helped, and I'll see you in the next one.